Hello, this is David Birch at Star Path School of Navigation in Seattle, Washington, with notes on more of our series of notes on buoy cam pictures. We're trying to get as much as we can out of these images. These are unique pictures of the ocean on cameras on buoys, and we need to be sure that we're looking in the right direction. And so I wanted, and we've had several little details behind this, so we've just kind of pieced together by working on it for a long time. And I don't know that there's any kind of references online for any of this information. So let's start out and just look at the issue. I want to put bearings on the cameras so we know what they are, which direction the buoy's looking. So here's the National Data Buoy Center with all of their buoys. Then you go up on the left and click Buoy Cams, and then here is let's see. Here are the buoys that have cameras on them. And these are the ones we were watching Florence go across these buoys here. We learned some things, but not quite yet as much as we want. But we're still working on this. So let's look at this buoy here. So on that view, I clicked that. It turned into a camera. Then if you roll right here, nothing happens. But you have to go outside the picture, and then scroll down. And there's the picture. Now, that's not so terribly interesting, but it's the middle of the night there. But so that's what happens. What we're going to have to do is we're going to have to catch a picture of sunrise or sunset. And we don't want to have to just set an alarm clock and get up at some strange time of night. We want to go straight to what we want. And that's what I want to show now. In other words, even though it's not advertised on here, we have very slowly figured out where they store these pictures. And so we can use that. So let's say this is a picture we wanted. And we look at this here. Let me click this link here. That takes us to the actual buoy place. Here's this picture in the middle of the night. Now, if you look at this buoy, look at this picture, and then look at the link that's down here at the bottom on the status bar. Or better still, we just click the picture. So here's the picture, and here's the link. So here is the first thing we notice. That these buoys, and let's see if I don't have a note about that. I started some notes, yeah. So here's this buoy, and buoys have two names. That's my note here. This buoy is 41044. But by brute force, by looking at this picture and looking at this link up here, we notice that there is a folder Zulu 09A. And that's the folder where those pictures are stored. And so what we need to do is, and they're stored in there, I haven't figured out how far back, but it's not real long, but it's maybe 2 or 3 days, maybe 3 days, but not much longer than that. But so for 3 days you can go back, but here we want to go back any one particular day. So the first thing though is we have to know when to look. So that's the thing. So even if you click this in the middle of the daytime and there's beautiful clouds and sun and clouds and one thing or another, you still have to go through the same exercise. You have to figure out what time was sunrise or sunset. So let's go through that exercise, and we go back here to the buoy. And then we look out, where is the buoy located? And there's 41044. It's located at that latitude and longitude. So I'm going to write that latitude and longitude down here. So I know where it's located. So the first thing I want to do is find out what is sunrise and sunset time at that longitude on that date. And the date we're talking about here is September 16. September 16. So there's a link at the U.S. Naval Observatory, and you can get to it with this shortcut link, starpath.com/USNO. And that'll take you, it'll take you to this link, which is one we're going to come back to. But once you get to this link, go to Data Services and then sunrise, sunset for one day. That ought to do it. Then on here you can go up. We want September 16. And then we want, here they list longitude first. That just keeps us on our toes. 5837. So that's 5837 minutes longitude west. Then latitude is north, and that is 2135. 2135. You definitely don't have to worry about the tenths. That's not going to matter. But we want this in Greenwich Mean Time, UTC. So we put in a 0 here and then get the answer. So here's the answer. So this would be telling you both the sunrise and sunset. You may be looking for, or you could do it twice. You could always go get the sunrise time and go get the sunset time. But let's just for now look at the, let's see, what time is it? 7. Yeah, the most recent one is this one, 2157. Now, did I write that in here? Yes. So I just copied that in my notes here. So the sunset is at 2157. So we might try 2110 or, 2100. Oh, okay. So here's another note. These pictures, let's go back here and get to the pictures again. These pictures are done every hour, and they're done at 10 minutes after the hour. That seems to be consistent. So we could look for a picture, and this is already on the 17th on Greenwich Mean Time. So we want to go to the 16th, and we want to go to, if sunset was at 2157, we would go back at least to 2010. Let's go to 2010. So just go in the address up here. This is all right. Change the date here to the 16, like that, and then change the time to 2010. 2010. Okay, and say enter. Now that's brought back the one for Z90A 9/16/2010. Now what do I have here? 9/16/21 2010. That looks pretty good but it's kind of a blur here. Let me try 21. That's the next hour. 2110. Okay. And this, we could use either one, but let's use 2110 because and also, okay, so we're going to use this picture, 2110 here. And then because we have a pretty good bearing to the sun, it's right here. That's the direction to the sunrise. Now we just have to figure what direction that is. This is also, you see, this sort of unusual. We see this in these buoy pictures a lot too, and I'm not exactly sure how that happens. These are right next to each other. It must be, I don't know how the lighting is set, or maybe they're not exactly sequential in time, but we've seen these alternate like this. Sometimes it's bright, darker, bright. I'm not sure. We have to assume for the time being that these are sequential, all taken at that time. Why the lighting on one is brighter than the other, we're still working on that. But we've seen that before. So that's the job. That's the picture we want. Then you can right-click and save that image. And that's what I have done. That's this image here. Is that correct? Yes. Okay, so that image is saved. So that's what we want. Now we just have to find out what is the direction to the sunrise at 2110 on a 9/16. So we go back to this page here, back to this link. Let's see, where did I have that? Here. USNO starpath.com/USNO. This has nothing, of course, to do with StarPath. We just made this as a built-in shortcut. It just gets you there from another. It's otherwise a complicated link, and you have to know the right path to get there and so on. So this will just get you to the right place, and that's here. Let's just go back here. Well, I'm going to just do it again. starpath.com/USNO. USNO. Enter. Okay, so there's the right page we want. You see, this is a little different than there's other pages here. This is the one we want. So now we've got this data, and we put this back in again. We want the 16th. And we want the hour now. Very specifically, we want 2110. We're going to do 2110. 2110. And we have to put the position back in, which is latitude north 2135. 2135. And then you put the longitude 5837. 5837. Okay, and then go get the data. All right, so there's the data. Okay, so that's what we want. I could maybe even just, let's see, I could just you see, there it is right there. The sun was about 10 degrees high at the time, and the bearing was 269, roughly 269. So that's the data. Let's see if I can cut and paste that. I'm using a Mac, by the way, which makes a big difference. It turns out, as far as I can tell, now maybe those who are really more experienced with PCs are going to have an easier way. I'm going to try to, once we see the process here, then I'm going to go to the graphics part on a PC as well as a Mac. But this part we're doing now doesn't matter what computer you use. But there's the answer we want. There's the whole answer we want. 269. 269. So on this picture, we want to put 269 right here. And we want to confirm that means that's 175 here. And if that's true, then we have calibrated this. And I do this because we've discovered one case, so far only one, where this number was wrong. We're looking into that, and we've talked to NOAA about it, and they're looking into it as well. But so if we're going to try to study these clouds and where the storms are and how to picture what's going on in the sky relative to the clouds, we want to be sure we know which direction we're looking, and that's why all this extra exercise. So 269. So there we go. Now, let's get to how you do this. And we also made something that's easy for you to do, help you do this. And that's this link here. And if you go to that link, Command C, go to a browser with that link here. There's a browser. And put that here, put that link here, Command V, and enter. You're going to get that picture. Now, this picture is this is a specially made picture here. This is a transparent background of exactly the right size. If you look at these images here and you look at the specs of them, they're going to come out 300 tall and 288. See, 288.80 times 300. All the pictures are going to, all the cameras around the world are going to all be that size. So we made this picture so it's going to exactly fit on here. And be transparent. So what you do is you save that to your computer. And again, I'm doing this first of all here with a Mac because it's a lot easier on to me it's easier on a Mac. I'll show you. Unless you have powerful tools. If you have things like Adobe, Photoshop, and things like that, then it's a cakewalk again on a PC. But you have to have that program and you have to know how to use it. But here is that, let's see, Buoy Cam Scale White. Here's the guy we want. So I open that one. So that's that picture I just downloaded. Now you just click on a Mac. I just click it anywhere. Say Command A. That copies that selects everything. Then Command C. That copies it. Now I'll come back to this picture we care about, which is over here, and then you just say Command V. Now then you can grab it. This thing, by the way, opened up in the stock program called Preview. That's loaded on every operating system of a Mac. So this is their base program. So there's the answer. So now we're done, almost done. What was our bearing here? Our bearing 269. So we want to take this guy and move it. I'm just grabbing that layer that came automatically. 269. There's 270. So that's about right there. So you could bring it down so you can see it. And that's a bearing to the sun. So that's that. So the first thing is we look over here. This says it's 175. And here's 175. Now that's as close as they get. These going to be usually plus or minus 15 degrees. We've only seen one where it was way over here, kind of like 30 degrees. Each one of these are 60. Every one of these are 60 degrees. Then I don't know how much this is going to stay in view. Then I'm going to bring this over here, click this, and then Command V and just paste it again and grab it and pull it down. And see, we left that number off this bottom here. So that'll just drop right down on top of that guy right there. Now you have your scale on the whole picture, and if we see it, we know the storm is somewhere over here or something, some bearing, whatever, then we can identify it. So that's the exercise, and that's all I wanted to show, except let me just give a hint then of how you can do this on a PC. PC. Oh, where's a PC? Actually, I'm going to make a second short video on a PC. That's the process, and that's on a Mac. If you are a PC user and have a good graphics program, then you don't need any more than that. If you not used to using graphics, then you can watch the PC program I'm going to do next, which is done with the PC program called that's on Windows 10 stock, called 3D Paint. It doesn't work in regular paint. I can't make it work in regular paint, but in the thing they call 3D paint, it seems to work. So I'm going to stop there. That's how we calibrate these pictures. And then later I'll show another a trick way for lining these up so the horizon all lines up smooth. Because of the waves, these are on buoys, so they're going to swing around a little bit. But your view of the sky is actually much more impressive when these are lined up. These cloud patterns make a little more sense when the pictures are lined up. But that's another graphics manipulation to go over later.